Hi guys, in this video we're going to be talking about permutations. So Colt is planning his Saturday. He wants to do laundry, go swimming, and do his homework. How many different ways are there to arrange what he wants to do? So we could do laundry, swimming, homework, laundry, homework, and then swimming. Then he could do swimming, swimming, homework, laundry. Then homework, laundry, swim, homework, swim, laundry. Okay, so how many different ways? 1, 2, 3, 4, 5, 6. So Colt is planning his Saturday, same situation. How many choices does he have for his first activity? He has 3 choices. It could be laundry, swimming, or homework. But then once the first activity is selected, how many choices do you have for the second? 2. Then for the third, there's just 1 left, so it's going to be 1. So there were 6 options, so what you can do is you can do 3 times 2 times 1 gets you 6 options. So a permutation is an arrangement or listing of objects which the order is important and the events depend on each other. So like you can't do swimming, laundry, you can only do it once. So Julia is scheduling her first 3 classes. Her choices are math, science, language, arts. Use the fundamental counting principle to find the number of different ways Julia can schedule her first 3 classes. Well, how many options does she have for her first? She's got 3, right? She could do math, science, or language arts. The first one's taken out. How many options are left? 2. Then the last one is 1. 3 times 2 times 1 gets me 6. An ice cream shop has 31 flavors, maybe Baskin-Robbins. Saad wants to buy a 3-scoop ice cream cone with 3 different flavors. How many could he buy if the order is important? Like it matters what order they are on. So for the first one, there's going to be 31 different options. 1 is picked. So how many for the second one? 30. How many for the third? 29. Or multiply. 31 times 30 times 29. So there are 26,970 options. Okay. We didn't multiply all the way down to 1 because he's not getting 31 scoops. He's only getting 3. How many ways can 6 people on a figure skating team stand in a row? Well, the first spot, there's 6 options. The second spot, there's 5 different people that could be there. 4, 3, 2, and 1. For this one, we went all the way down to 1 to that last spot because it does matter and everyone's included. 6 times 5 times 4 times 3 times 2 times 1 gets me 720 ways. Okay, race with 7 runners. How many ways can they end up in first, second, and third? Well, that's going to be 7 times 6 times 5. Gets me 210 different ways. Again, only 3 places. We didn't go all the whole entire way. How many different ways for all 7? It's just first, second, and third. So the symbol P, and then the first number is 31, represents the number of permutations and taken 3 times. So this is the way that it was for the Baskin-Robbins question, where it was 31 different options, but we only wanted the first 3. So again, 31 times 30 times 29, it's going to be that same answer. But this is the way that it can be written. So 8, permutation, the probability of 8 in the first 3. So 8 times 7 times 6. Gets me 336. So 12, but just the first 2. So 12 times 11 is 132. So 4, all 4 options. So 4 times 3 times 2 times 1 gets me 24. 10 times 9 times 8 times 7 times 6, 5 different ones. 10 times 9 times 8 times 7 times 6, 30,240. Your phone passcode has 5 digits. If one digit is not repeated, how many codes are possible? So how many options are there for the first number? Well, there's 10 because 987654321 times 9 times 8 times 7 times 6, because it's 5 digits. So 10 times 9 times 8 times 7 times 6, 30,240. The Battle of the Bands contest, how many ways can the band participating perform? Well, there's 4 different options. 4 times 3 times 2 times 1. 24. Last one. How many permutations are possible for the letters in the word friend? Well, how many letters are there? 1, 2, 3, 4, 5, 6. So 6 times 5 times 4 times 3 times 2 times 1, all the way to the end. 720.